Alrighty, this is my, I guess, part 3 video of the section 7.4, which is adding and subtracting rational functions. This example is specifically about complex fractions because I know what you're thinking, Miss B, what in heaven's name have you brought into my life? And here I am helping you because I care. So let's work this problem out here. So in class I talked about there's kind of an easy way to do it and there's a hard way to do it. The easy way to do it is to find the least common denominator of all of the denominators. So we need to do that. The first thing that you're going to want to do is factor the denominators, but in this case, in this example, all of the denominators are already factored, so we don't need to do that. So we just need to look at all the denominators and take the highest power of each factor. Here we've only got an x minus 2, so we just need one x minus 2. Here we've got an x minus 2. Great. That's awesome. We already have one. And here we have an x, so we just need a times x. That's our least common denominator here. Okay. Now here's where things go a little bit differently than the rest of the section. I'm going to rewrite it here. All right. I'm going to rewrite it like this. Same thing. I haven't done anything yet. But what I'm going to do is I'm going to multiply each of these fractions by the least common denominator. So I'm not binding... I'm not changing it so they all have the same denominator. Essentially, that's what I'm doing, okay? But what I'm going to do is I'm going to multiply by the least common denominator itself. So not just what the denominator is missing, but by the whole least common denominator. So I need to multiply the top by an x times x minus 2. All I did was bring that x out in front, okay? I like it there better. Then we need to multiply this fraction by the least common denominator, which is x times x minus 2. And then I'm going to multiply this one, x times x minus 2. So notice I have not multiplied the top and the bottom, okay? If you wanted to, you could take the same approach and do it that way, but you would still end up with a bunch of denominators, and it would work. And if you care that much, then come see me, and I'll show you why it works. But for those of you, most of you that I know don't care, just multiply everything by the least common denominator, okay? So here's what's going to happen. I'm going to take the long way around. You might be able to skip this step. You might not, but it's up to you. All right, so now let's take 6 times x minus 2. Okay, I just took the 6 and multiplied it by this. The denominator stays the same, okay, because when you've only multiplied by one thing, you just multiply it by the numerator. All right, in our huge denominator here, we've got 1 times x minus 2, which is just x times x minus 2, all over x minus 2. And then here we've got 3 times x minus 2, so we've just got 3x times x minus 2. Great. All over x. Okay, now here's why this is helpful. Right now you're looking at me going, Miss B, we have totally just made it worse. No, we haven't, because watch what happens. Okay. Before we do any canceling, which is what I'm about to do, let's restrict our domain here. So anything that's a denominator, we've got here. We've got an x minus 2, so that means that x cannot be 2. We've taken care of that one. And then x cannot be 0. Now, we're going to come back to these restrictions a couple of times. But for now, we just need to understand that that's a denominator, that's a denominator, and that's a denominator. So we need to eliminate what would make those 0, and that's what we did. Okay? Now let's cancel. Look at this. X minus 2 cancels with an x minus 2. Okay? That leaves us with just a 6x in the numerator. Well, that's much prettier than what we started with. Okay? And x minus 2 cancels with an x minus 2, so now we're just left with an x. Okay? And then an x cancels with an x, so now we're left with a plus 3 times x minus 2. Now that looks much better than that up there. Don't you agree? That's why this works. It makes things nicer. So now let's simplify. We can't really do anything with 6 times x, so let's just leave it as 6x here. Okay? This x can just stay x, but we can distribute this 3 here. So 3 times x is 3x. 3 times a negative 2 is a minus 6. Okay, let's keep going. Numerator stays as a 6x. X plus 3x is a 4x. Minus 6 doesn't have a friend, so it just stays a minus 6. All right. Now what we can do is, now we can simplify. By this I mean, the numerator can just say 6x for now, but this has a common factor of 2. All right, 4x and 6 have a common factor of 2. What I'm left with is a 2x minus 3. And the reason why I did this is because 6 and 2 can now be simplified. 6 over 2 can be simplified to 3 over 1. All right, so now we've really got 3x over 2x minus 3. Okay, now a lot of you on your quiz like to cancel those and say, oh, they have an x. Well, 3 doesn't. You can't do that. No, I'm going to throw my shoe. Okay, don't do it. Okay, this is all that you can do. There's nothing left in this world that you could do to that to give you a better answer. However, we now need to restrict this in our domain. So we set 2x minus 3 equal to 0. Okay, add 3, 2x equals 3, divide by 2, x equals 3 over 2. So we know this denominator is 0 when x is 3 halves. We can't have that happen, so we have to come back up here to our domain. X cannot be 3 over 2. That's bad. So there's the second part of your answer. Okay? Main things here that I need you just to really, I just need to drill them into your head. Multiply by the least common denominator, not just what the denominator is missing. Okay? Everything. That way you can cancel here. If you were to multiply by what the denominator is missing, you would create like denominators and then you could simplify from there. But like I said, that's a long way around. Don't do it unless you're just really feeling it. Okay? Then once everything simplifies, you can be down here. Great, awesome, simplified. Don't forget to factor in the end if you're able to factor like we were here. Simplify, and don't forget to restrict your domain. Go back, look at every single denominator. Is there ever a time that those could be 0? You must restrict them. Alrighty. Yeah, I know that those are a little bit more difficult, but hopefully this video helped. Rewind, pause, do whatever you need to do. Thanks for watching.